So hello guys, in this video we are talking about how sorting can reduce data skew by 8899 in Apache Spark. So what is data skew? Data skew occurs when one or few key contain significantly more records with other key, cause those records to land in same partitioning. Create fat partition that make much longer to process than other. How to spot skew in Spark UI? We have to go Spark UI, then stage page, then task matrix. One or few tasks have dynamically longer duration. Then check task timeline, a few long bars or many short bars. Then shuffle read size. One task read far more data than others. So what is sorting? Sorting means adding random number. Adding random number means sort, and sorting means adding random number to join or aggregation key. So that row that previously is hashed to the same partition, how hash to different partition. Sort number. A sort number control how many blocks you split the skew data into. So let's talk about let's talk about questions. What is data skew in Spark and why it is a problem? Data skew occurs when one or more partition key contain significantly more data than others. Because Spark use hash key percent shuffle partition to root rows during shuffle. All rows with the same key always land in same partition and are processed by the same executor task. Again, Spark key occur when one or few partition key contain significant more data than others. Because Spark use hash key and hash key percentage shuffle partition to root rows during shuffle. All rows with the same key always land into the same partition and are passed by the same executed task. The problem is that Spark stage only complete when all tasks finish. If one task process 1 million records while other process 5 rows each, the entire stage wait for that slow task, making the job as slow as its worst partition. This is called stager task. Stageral task. Explain the sorting technique for join. What are the exact steps? Sorting resolve joins queue by adding random number means sort to the join key, breaking one large partition into multiple small one. Steps. Choose sort number typically equal to shuffle partition. If if we did shuffle partition is 5 10, then sort number is 5 or 10. Then next step is add random integer from 0 to sort number -1 to the skew means larger dataset as new sort column. Then export the new non-skewed smaller dataset for each row. Create sort number row one for each sort value. Means एक टेबल मोठा एक टेबल लहान आहे एक मोठा टेबल आहे त्यामध्ये सॉर्ट नावाचा कॉलम करायचा आणि त्यामध्ये 0 टू सॉर्ट नंबर -1 ह्या व्हॅल्यू टाकायचा. समजा सॉर्ट नंबर 3 आहे तर 0 1 2 हे 3 व्हॅल्यू परत एक रोला जाणार एक रेकॉर्डला जाणार मोठ्या टेबलमध्ये. आणि नॉन स्क्यू डेटासेट म्हणजे स्मॉलर डेटासेट. त्या डेटासेटमध्ये आपण सॉर्ट अंडरस्कोर नंबर हे कॉलम करायचा आणि त्यामध्ये ॲरे पास करायचा. फोर्थ स्टेप इज जॉइन दॅट टू डेटासेट ऑन ओरिजिनल की अँड सॉर्ट इंस्टेड ऑफ जस्ट जॉइन ऑन ओरिजिनल की. Then larger and smaller dataset we have to join based on the original key plus sort column that we created in both dataset, and that we have 0 1 0 or 1 or 2 numbers. Now rows that previously all hashed the same partition means same key minus hash key. Now hash differently because hash of key comma sort is equal to 0, hash of key comma sort is equal to 2, and hash of key comma sort is equal to produces difference result. The crucial rule: always explore the smaller dataset because explore multiple rows by sort number. Exploring the large dataset would be making worst. Next question: how does sorting work for aggregation? Why is the two-phase approach needed? For aggregation, you cannot simply add sort column and do single group by. That would go wrong result. You had to get one row per value sort instead of one row per value. This is correct approach in two-phase aggregation. Phase 1: partial aggregation. It is distributed. Add a sort number, then group by key comma sort and compute the partition aggregate. Sort distributes the key skew data across partition. Example: 1 million record means 1 million rows with key is equal to 0, split into 3 stages for 333 k each aggregation independently. Phase 2: final merge. Lightweight. It is a lightweight group by of key on the output of phase 1, which now has at most distinct key into sort number, row number. Tiny dataset. Merge the partial aggregation. Example: sum of a partial count value. This work cleanly for count, sum, max, mean, and for average you must track sum and count separately in phase 1 and compute count and sum in phase 2. Count sum divided by count in phase 2. Then so what is the difference between sorting and broadcast join for handling skew? Sorting and broadcast join. Mechanism in sorting is distributed skew key across partition, and in broadcast sends small table to all executor, no shuffle. Sorting applicable when both tables are large. Broadcast join applicable when one table is small, means fit in memory, typically less than 10 MB default. Complexity in sorting required code changes, and in broadcast join one line solution, means df dot join in bracket broadcast in bracket table name, then join condition and type of join. Then work for aggregation. Sorting yes, broadcast join not capable. EQU equivalent. AQE skew join in sorting, and in broadcast AQE auto broadcasted. Broadcast join means simplest solution when one table is small. Always prefer broadcast join over sorting when the non-skew table fit in memory. It eliminates the shuffle entirely, not just the redistributes it. Next question: what is AQE and how does it automatically handle skew? What are its limitations? AQE means adaptive query execution, introduced in Spark 3.0. It is a runtime optimization that adjusts query plan based on actual data statistics over reviewing execution. For skew, AQE skew join feature. First, observe actual partition size after shuffle stage completes. Identify partitions that are skew, means size is greater than skew partition factor into median and greater than skewed partition threshold in byte. Automatically split those large partition into sub-partition. Fourth, match the split partition against the corresponding data from other side of join. Limitation of AQE: only handle join skew, not aggregation skew. Manually sorting is still needed for a group by. Next, may not be sufficient for extreme skew. 99% of data one key. Add the runtime overhead, means AQE collect static at each shuffle boundary. Not available in structured streaming, means batch. It is available for batch only. The threshold parameter may need tuning for large dataset. Next question: if sort number is too high, what problem can occur? Setting sort number is too high. Main two problem we will get. First, dataset explosion on the small table. The non-skew means small dataset is skewed by sort number. If the small table has 10 million rows and sort number is equal to 100, it becomes 1 billion rows, which can cause out of memory error and exclusive disk input output. Second is dimension return. The shuffle sort is equal to 200 and sort number is 200. You are splitting 1 million row into 200 group of 5000 rows each. म्हणजे 5000 रो 2000 ग्रुपमध्ये, म्हणजे प्रत्येक ग्रुपमध्ये 5000 रो आहेत, असे 200 ग्रुप आहेत. गोइंग टू सॉर्ट नंबर इज इक्वल टू 400. ओनली स्प्लिट देम इंटू 500 rows per group. This improvement is magnificent but explosion cost double. Best practice is set sort number is equal to or small multiply of spark.sql.shuffle partitions. Start with partition shuffle partition count and increase only if skew persists. How would you detect and diagnose data skew without looking at Spark UI? First method is check partition distribution, means cdf dot with column in bracket partition comma f dot partition spark underscore partition underscore id bracket, then group by on partition, then count, and then order by count decreasing and show 20 records. If max count is greater than medium count, then skew exists. Method 2, check key distribution directly, means df dot group by on join key, then dot count dot group by count decreasing, order by count decreasing, show 10. Top keys with massive count are your skew data. Method 3, statistical summary, means df dot key dot count. In select we have to take max count, average count, expression means percentage, means medium count, and percentile of 0.95. You have to take percentage 0.5. Skew if max greater than medium. For example, maximum size is 1 million and medium is 10, then extreme skew. And next question is, what happened to the join result correctness after sorting? How sorting change the output? No. Does sorting, sorry, question again, I will repeat the question. What happened to join result correctness after sorting? Does sorting change the output? No. Sorting does not change the correctness of the join result. The final output is identical to non-sorted join. Here why? Because each row in skew data has a random sort value. For example, sort is equal to 1. The small data set has been explored to contain all slot value, means sort 1, 0, 2. For every key comma sort is equal to row in skew dataset, there is exact one matching key comma sort is equal to 1 row in the explored small dataset. The join correctly match them. The sort number is synthetic routing key. It changes where clause are processed with partition, not which row match each other. After the join, you drop the sort column and get the same result as without sorting. Real world project scenario. E-commerce skew over order enrichment. Most common question. Problem is, you work at e-commerce company. You daily pipeline joins order fact table that having 500 million record with a customer dimension table with 10 million rows. The join key is customer ID. You cover that 5 super seller market count each have 50 million plus order, means 80% of data. Those 5 key cause extreme skew. Diagnosis: top customer order. How you can check that? Like we have to write a query like dev order dot group by based on customer ID count, then check count order by count decreasing order show. Then we will get the numbers like customer ID is equal to 0 C001 having 52 million rows. Then dev customer ID CC002 having 48 million rows, like that. So solution is like we have to import storage level from PySpark, then sort number is equal to 50, high sort for extreme skew. Step 1, sort the large order table, means df orders skew, df order skew is equal to df order dot with column sort r comma yep in bracket yep dot rand into sort number bracket complete cast in int. Step 2, explore customer table, means having a small table. In that we have to add column sort arr, and we have to give array in bracket lit I for I in range of sort number. Then also we have to add another column called sort explore sort array and drop explore sort array column. Then we have to catch the explorer data table, then using df and customer explore dot persist in bracket storage level dot memory only disk. The third step is join based on the customer ID comma salt. You have to use left join and drop salt, then write into the Parquet file and unpersisted data frame. Result is like job that previously run for 4 hours now complete in 20 minutes. Fail. Next question. Problem is it is a Skew daily transaction aggregation. Problem is you process payments platform transactions when computing daily sum of count and count star by merchant ID. A handful of larger merchants, means Amazon, Walmart, have 10 million plus transactions per day, while most merchants have few than 100. Standard group by processes stream aggregation queue. Solution is like phase sort aggregation. Sort number is 200, large enough to split 10 million rows into manageable chunks. So we have to create one data frame called daily merge slash, and in that we have to take df underscore transaction. We have to filter based on status is double equal to success. Then we have to add a column sort and based on rand into sort number cast in int. Then we have to group by based on merchant ID and transaction date plus sort, and aggregate on count sum. We have to take aggregation like sum of count, then maximum of amount, sum of amount, count, sum of amount and minimum amount. Then phase 2, final merge. First phase is add sort and partition aggregation. Second phase is final merge. In that group by merchant ID and tax transaction date, and aggregate based on aggregation on sum of partial sum of partial count, sum of like partial max. Partial sum means we alias as a total number. Then finally we have to write into the Parquet file. Next scenario is like null key skew frequently overloaded. Your join key contain large number of null values, perhaps due to data quality issue upstream. All null value hash to the same partition cause the skew event cause the म्हणजे डेटा फ्रेममध्ये कस्टमर आय डी आहे आणि त्या डेटा फ्रेम नल व्हॅल्यू खूप आहे त्या कॉलममधनं कस्टमर आय डीमध्ये. सोल्युशन इज हँडल null before sorting. Option 1, filter out the null value before join. Option 2, replace null value with unique key per row, and each null get the unique key using monolithic increasing ID. Spread across all partition, null will never match anything in the right table. Wait to fill. Next question is AQE plus manual sorting hybrid for production. Problem is you are building production grid pipeline where some join key are midly skew, means AQE can handle, but one specific key is catastrophically skewed, means 99% of data. You want AQU to safely native, but manual sorting for known bad keys. Solution: pre-split the hotkey. So we have to enable AQU using spark.config.set in brackets spark.sql.adaptive.enable true, then spark.sql.adaptive.join key .enable true, then sort number is 100, then hotkey is equal to super merchant underscore 001 hotkey. Then split the problem, handle the known hotkey with sorting and rest with AQE. Then you have to create two data frames based on df hot is equal to df order dot filter in bracket merchant id is equal to hotkey, and you have to create another data frame called df rest is equal to df order dot filter based on merchant id not equal to hotkey. On a hotkey is super merchant 001. First we have to sorting for the hotkey only, means df hot. In df hot we have to create another column called sort and ran into sort number, cast into int. Then merchant hot, create data frame like you have to filter we have to df merchant dot filter df merchant dot filter is equal to merchant id is equal to double equal to hotkey with column sort array. We have to create a new column called sort array, and in that array lead means array should be 0 to sort -1, and then again we have to create another column sort, and we have to explode that sort array and drop the sort array column, and that data frame we are calling as df merchant hot. Then that we have to join df hot sorted join with df merchant hot based on merchant id and sort. You have to use left join and drop sort. Then EQ handle the rest moderate queue and union to result, means df hot join dot union df hot join dot union in bracket df rest join, and create new data frame called df final. Quick reference cheat code. Detect skew group by key dot count dot group by in bracket order count dot order by count decreasing. Sort the key skew df